Did you know there is a star out there so big that if you dropped it into our solar system, it would swallow Mercury, Venus, Earth, Mars, and Jupiter, and keep going until its surface reached Saturn's orbit? Not metaphorically. That is a real star, sitting 18,900 light-years away, and the light you would need to see it left before humans invented writing. It has looked exactly like this for that long. For decades, we looked at stars and saw fixed points of light, tiny, distant, permanent. We called them eternal. We named constellations after them and assumed they would outlive us by forever. We were right that some of them are beautiful. We were catastrophically wrong about almost everything else. This star, Stephenson 2-18, isn't even a dot you can see. Point every backyard telescope on Earth at its coordinates, and you will see nothing but black. Not because it is dim. It is one of the most luminous objects in the galaxy. Because there are thousands of light-years of gas and dust sitting directly in the way, swallowing its light before it ever reaches us. We only found it by looking in infrared. Now let's talk about the size, because what sounds like a number is actually a monster. Stephenson 2-18 has a radius roughly 2,150 times that of our Sun. Its volume is estimated at 10 billion times the Sun's. You could pour 10 billion suns into this thing and still have room. And unlike our Sun, its own gravity is losing. A star this bloated can no longer hold on to itself the way a normal star does. It is not exploding. It is worse than that. It is quietly, continuously bleeding, shedding its own outer layers into space as a slow wind of gas and dust, every single day, forever, until there's nothing left to bleed. This is the star we call the biggest in the universe. Now let's talk about the neighborhood it came from, because a monster like this doesn't grow up alone. From a distance, if you could actually see it, Stephenson 2-18 sits among embers scattered in the dark heart of the Milky Way, inside a stellar nursery called Stephenson 2. But this isn't just a nursery, it's a graveyard already being built. At its core, astronomers have confirmed at least 26 red supergiant stars, dying giants, all in the same tiny patch of sky. Widen the search, and the number climbs past 80 candidates, with around 40 confirmed as true members by their motion through space. Some researchers believe this cluster is part of an even larger structure, one that could contain hundreds of red supergiants scattered along the same spiral arm. It may be the most massive young star cluster ever found in our galaxy. And every single one of those hundreds of giants is on the same countdown Stephenson 2-18 is on. Because here is the part that changes everything. A star this big is not aging gracefully. It is dying, layer by layer from the inside out. Massive stars burn through their fuel violently fast. Our Sun will spend roughly 10 billion years quietly fusing hydrogen. A star like this one exhausts its hydrogen in around 10 million years, then spends only a few 100,000 more as a red supergiant before the end. Deep in its core, it is already fusing heavier and heavier elements in layers, like an onion built out of fire, each layer burning faster than the last, racing toward a moment when the core turns to iron and can no longer hold itself up. When that happens, the collapse takes a fraction of a second. What follows is a supernova, one of the most violent explosions in the universe, leaving behind either a neutron star or, if the collapse is severe enough, a black hole. We have already caught massive stars doing this in real time. In 2009, astronomers watched a supergiant in another galaxy simply vanish from Hubble's images over several years, with no visible explosion at all. The leading explanation being that it collapsed straight into a black hole without a proper supernova. But the size itself is where physics stops making sense. Stellar evolution models set a hard theoretical ceiling on how large a star in our galaxy can get, around 1,500 solar radii. Past that point, models say a star should be too unstable to hold together at all. Stephenson 2-18 is measured at roughly 2,150 solar radii. 650 radii past the line where it supposedly isn't allowed to exist. Astronomers don't fully know why it's this big. They don't fully agree on exactly how far away it is, which is the number the whole size estimate depends on. It just sits there, in the dust, defying the ceiling. We have never taken a close-up image of its surface. It is too far, too buried in dust for even our best interferometers to resolve. But we have imaged its cousins, and what we've seen is unsettling. Betelgeuse, the red supergiant marking Orion's shoulder, the one star of this type most people have actually heard of, has been mapped by telescopes in Chile. And instead of millions of small convective cells, like the ones bubbling across our sun's surface, it shows just a handful of monster cells, each one covering more than half the star's radius. In 2019, Betelgeuse suddenly and dramatically dimmed, visible to the naked eye from Earth. Follow-up observations found the cause. The star had blasted a piece of its own surface into space, a cloud of hot gas hundreds of billions of times more massive than anything our sun has ever ejected, which cooled into dust and blocked its light. A star having what amounts to a partial, violent shedding of itself, visible from another planet. And Betelgeuse, for all that drama, is barely a third the size of Stephenson 2-18. If Betelgeuse is a warning shot, one star already showed us what the final act looks like. In 2024, astronomers using the European Southern Observatory's Very Large Telescope Interferometer captured the first ever close-up image of a star outside our own galaxy. WOH G64, a red supergiant roughly 1,540 to 1,730 solar radii across, sitting in the Large Magellanic Cloud. The image revealed something no one expected. The star, wrapped in a dense, egg-shaped cocoon of its own expelled dust, a shroud it had spun around itself while preparing, astronomers believe, for its own supernova. We built an instrument, pointed it across intergalactic space, and photographed a star getting ready to die. Stephenson 2-18 was built from the same physics. It will end the same way. We just don't know when. Because of the distance, we are watching light that left this star 18,900 years ago. If it already exploded the week after that light departed, we would have no way of knowing. It could already be gone. The version we're looking at, the record-holding giant defying the size limit of stars, might already be a corpse whose last light simply hasn't reached us yet. Look at it while you can, because whether it happens tonight or in 10,000 years, this titanic, physics-defying monster is going to die, and the universe will not slow down to notice.